Hi, welcome to this tutorial. This is the final part of question 5 from NECTA Basic Applied Mathematics paper 2017, and this part is to do with volume of revolution. Okay, so we are told the area bounded by the lines y equals mx, y equals h, y equals 0, and x is 0 is rotated about y-axis. If x is equal to r when y equals h, find the volume of the figure generated in terms of h and r. Okay, so there's some sort of area, and that area, that region, is being rotated. Okay, so let's just put that on the x and y plane. Okay, so first of all, there is some sort of line which is y equals mx. So I'm just going to draw that line. That line is going to go through the origin because we have y equals mx. We don't know what the gradient is, but it is going through the origin. Okay, so that is one of the line that this region is bounded at, and another line is y equal to 0, so this line here, and another line x equals 0, so it's this area here, this line here, anything from that area, and then y equals h. So let's say at this point y is h, this region. So this is the area that is being rotated, and then we are told if x equals r when y equals h. So h is here, that means r is here, so we got r here, and this point is rh then. Okay, so y-axis, x-axis. Now what you need to do is imagine this area in blue is being rotated on the y-axis. So I'm just going to draw the rest of it here like this. Okay, so you got to imagine when it's been rotated, okay, that way you will get something like a cone. Okay, and this region that is covered in this cone is the volume that we need to find. Okay, so let's find the volume of the region. Okay, change my color. All right, so volume is given by the integral of pi. Now, because we are rotating in the y-axis, we need to write x squared and dy. Okay, now what are the regions? Well, this area has been rotated from 0, this is 0, 0, to this point where y equals h. So from 0 to h. Okay, now what are we going to do? We've got dy, then we've got x squared. We need to find a way to write something, this x, in terms of y. Well, we know y is equal to mx, that's from the information that we have, and therefore x is equal to y over m. Okay, so now let us substitute x there into our integration. So y equals 0 to h. Pi is a constant, it can come outside, so instead of x we now write y over m, but it needs to be squared, so dy. So if we again take this out, simplify as much as you can, so that's pi, and then m is a constant because it's a gradient of a straight line, so that can come outside, and then integral from 0 to h of y squared dy. Okay, so what do we get? We're going to integrate that, so that v is equal to pi m squared, and then if you integrate y squared, you get y cubed over 3. So this will give you sorry, and the limits are from 0 to h. Let us put the limits in. Wow, did I put a 0 there? It's h. Okay, so if you put this in, you will get pi h cubed over 3m squared. No point putting 0 because you just end up with 0. Okay, this is not our final answer because we're asked to write in terms of h and r. So we know m is gradient. Gradient is difference in y divided by difference in x. So that's h and that's r. So m is equal to h over r, and substitute that in. So volume is equal to pi h cubed over 3, and then we got h over r needs to be squared. Okay, so if we rearrange this, then we'll have the r square on top, so we got pi r squared, the h cubed, and then divide by the h square, you'll be left with h, and then you will just have 3 as a denominator, and that is your volume, so cubic units. Okay, so that is the solution for this question. Please, if I have helped you, press like and subscribe. See you again.